we got good group of people here. Thanks for joining, everyone. We'll get started. Excited to host John for his third LogRocket meetup. If you want to view John's previous recordings, I'll link them in the recording of this. So in case you can't hang out the whole time, the recording will go out. So yeah, in the past we've covered, let's see, React and SEO. We've covered, what was the first TypeScript meetup?
It was
TypeScript 4.4 and like the some of the new features there.
Yeah, that was it.
Yeah, I'll send those around with this recording. But yeah, so today we're covering JSDoc, which is something I'd never heard of before. So I'm excited to learn more about it. Yeah, just a couple of quick plugs here. We've got a couple more meetups coming. We had a really interesting GraphQL one a couple weeks ago around caching, so I'm excited for this one. And then a really kind of broad, like React versus Next.js, like 500 people have signed up for that already. Yeah, if you want to sign up for any, that's just on the blog /tech meetups. It's also a link in the header now. And yeah, this kind of meetup's brought to you by LogRocket. And yeah, we're a front-end monitoring solution, help you ship better apps, fix issues more quickly. Just wanted to quickly highlight something we've been working on quite a bit. So it's kind of a combination of session replay to see what happened, what went wrong, and an error aggregation monitoring tool like a Sentry or backend logging tool. So right now I'm looking at our issues tab, and we've just added these recent kind of issues types. So once you install LogRocket, we automatically surface any kind of exception, any kind of error from a network request or just from the JavaScript layer. But we also just added this frustrating networks request filter type. So if you've got, you're asking an API or a third-party service for, a network request, and it's either really slow or it's failing, and then that causes a UX issue. So someone's kind of like very frustrated and trying to click something that's not doing anything, or just, something's not loading properly. We now kind of separate those out so you can go see people who suffered this issue, what exactly happened to them, and then, go actually fix the issue a lot more quickly. So yeah, if you want to try something out, have any questions about LogRocket, shoot me an email at luke@logrocket.com, drop a message here. But yeah, the chat's open. I'm going to pass it over to John and we can get started.
Sure. That's quite apart from everything else. I like the color scheme on your the screen that you had up there. It's like nice pastels. Yeah,
the funnest thing is like actually getting the green up to 100%, which is like impossible and never actually happens. But it has on some smaller stuff, not on like big production stuff. There's always errors on everything. Yeah, people are like, we don't have any issues on our apps. Like, you just don't know them.
You just haven't looked.
Yeah, you just haven't seen them. You should be good to start.
Cool, thanks. Let me share my screen. Where's the button? And I want to share my yep, there we go. And I bounce over to here. I'm just going to close that. Hopefully people can see my screen. Let me know if you can't. Cool, let's start. So this talk is called TypeScript Alternatives, JSDoc JavaScript, and it's just slightly facetious name because actually it is kind of like TypeScript behind the scenes, but yeah, we'll get into the distinction in a moment. Who am I? I'm John Riley, Johnny Riley on the socials, sometimes with an underscore, sometimes without. I blog a lot, fair amount with LogRocket as well. I write open source software. I'm quite part of the TypeScript ecosystem. I work on Definitely Types, TS Loader, and a few other things like that. And actually, related to this project, I contributed loader context static typing to Webpack, and but that won't mean anything right now. Don't worry, it will a little bit later on. So, TypeScript. A fairly simple way to understand TypeScript is that it's JavaScript plus static typing. And classically, the way that you would use TypeScript is that you write TypeScript files in .ts files, and you compile them and get JavaScript files. And actually, that compilation step is kind of an interesting one, because there's two things that are happening there that are interesting. One of which is you're taking TypeScript files and you're removing, erasing the types from them and pumping out JavaScript that can be run in the context of a browser or Node or something else. And the other part is type checking. So looking at your program and saying, okay, do all the guarantees hold up? Are there any silly mistakes in here? Any typos? That kind of thing. Just catching that kind of stuff. And static typing is just like generally an attractive property for programming languages. Like, I would argue, it's just a great way to catch all kinds of issues before they end up in the hands of customers. Arguably, it reduces the need for your tests and things like that. Sometimes a controversial opinion. And JSDoc JavaScript is a way that you can use the comments inside JavaScript to power type definitions and similar. To back up a little bit, let's talk about what JSDoc is. This is an explanation from Wikipedia. JSDoc is a markup language used to annotate JavaScript source code files using comments containing JSDoc. Programmers can add documentation describing the application programming interface of the code they're creating, which is quite old, actually, JSDoc. It came about in 1999, was originally used for all kinds of different purposes. In fact, I think the most famous purpose, like before TypeScript, was, I think it was used to power the Google Closure compiler, which is another version of applying static typing to JavaScript. And with TypeScript 2.3, an exciting new feature arrived called CheckJS. And TypeScript, right from the very beginning, had been like super focused. Like, the team had been super like interested in making it easier for people to adopt TypeScript. And one of the things they did along the way was they introduced a compiler flag called allow.js. And allow.js kind of did what the name suggested, which was it allowed you to mix in plain JavaScript with your TypeScript code base. And CheckJS was kind of like an evolution of that. CheckJS said, okay, well, we've got some JavaScript in the code base. What about applying the TypeScript, like type checking, to that? And some of that can be achieved through inference. Like the TypeScript compiler is pretty good at inferring types from code that it reads, and JavaScript code is TypeScript code, so that would still work. But obviously, there's a place where inference doesn't work out for like complex types and similar. And that was facilitated through use of JSDoc, like taking JSDoc as an idea and evolving it slightly to meet the needs of TypeScript. And so what you got was something like this. So if you look at this this code here, we have a super simple piece of TypeScript here. This simply is a variable declaration for a variable called myString, which has the type string. And if you wanted to do the same thing using JavaScript JSDoc, instead of having this bit of TypeScript here, what you'd have is this bit of JavaScript here, just the let myString. So this part here is identical, right? But you'd strip off the type annotation there, and instead, in a comment beforehand, you have the / and then 2 asterisks with the @type, and then inside the curly braces, you have the actual type. And just to show you what that looks like in the context of VS Code, here we can see that we've got a myString variable and the type is string, and that's powered by this thing here, which is tremendous. So we've looked at what the simplest like transposition, I guess, would be. Let's take a look at functions, something slightly more complicated. So functions, you can see in the original form, have the type annotations to the right of the parameter name. And when they're transposed into their type form, and I'll actually bounce across again into VS Code to look at this, because it's a nicer presentation than inside there. If you go from function TS, which looks like this, to function JS, you can see that again, you've got P1 and P2 and P3 all picking up their types. They're picking them up from this lump of JSDoc above. And I think you're probably like starting to notice here that like it's a bit more verbose using JSDoc, and this is kind of like one of the downsides of it. But it is like just JavaScript code, right? It's just JavaScript code. And you could apply this to any JavaScript code base. That possibility is there. Now, we're going to take one step further to objects. And this is where it starts to get, in my opinion, a little bit hairier. So you've got a type definition here, or for an object type. And it's fairly straightforward how it looks. And if we look at the TypeScript, you can see, yeah, it's quite nice. This could also be an interface, by the way. I just use type because. And if you were to do the same thing in the context of JavaScript, it would look like this. And you can see we've got the same type stuff flowing through. It's marvelous, but it is, yeah, it's undeniably more verbose. Like it really just, yeah, it's harder to read, it's harder to follow. I mean, VS Code's actually doing a great job here in terms of like syntax highlighting and all that kind of stuff, but it's yeah, it's just harder to get to understand. But actually, like there's a marvelous like compromise which is possible, and what you can do is you can do like a best of both worlds type thing. You can write your runtime code in JavaScript, but you can put your complex types in declaration files. So just as a recap for someone who isn't so au fait with TypeScript, there's kind of like two sorts of TypeScript files that you can write. Actually, if you include React in there, there's more, but let's just think of it as two. And one sort is runtime files, so files that contain code that will be transpiled and run. And one is declaration files, and declaration files like declare the shape of objects which can be used for other purposes. So like in the case of definitely typed, we use declaration files so that we can define the definition of libraries that don't directly ship their own types. And what you can do is you can put your complex types inside a types.ts file. So you're actually writing TypeScript, but TypeScript is never actually going to have any runtime properties. It's never going to ship. And then just import that into the context of your JavaScript file. So you can do the hard typing stuff there in like a nicer syntax experience, and then you can use it in the context of your JavaScript files through declaration imports. So this is like a middle ground that gives you like a better experience when you're using it. So we've talked so far about what JSDoc looks like and how you might use it, like just getting like a feel for like the syntax and how it works and all that kind of stuff. I think the story was actually quite interesting too. And so, as we said, TypeScript shipped in 2.3 with like JSDoc support, and it was just an experiment, as they said. It was something to try out and like, oh, let's see what happens if we do this. And the experiment was good and people liked it, but it was kind of like under the radar, and actually, arguably to a certain extent, still is under the radar. But what happened is that a wonderful man called Mohsen Azami, and I may well be pronouncing his name wrong. If he should ever hear this, my apologies, did a pull request to Webpack. And it was quite an exciting pull request. Let me just open up the link here. And this pull request added TypeScript type checking support through JSDoc to Webpack. And it was a fairly beefy PR, and it went on for a little while, and it was just an experiment really to see like would it work, like type checking a large JavaScript code base, which Webpack certainly was. Webpack, by the way, is in case you don't know, is a bundler of JavaScript for the web. It's a very widely used project, and it's a significant JavaScript code base. So this is a very interesting place to apply the JSDoc CheckJS support to. It's like if we apply this like a really big code base, like what does it look like? This is how you find out like how things like work out really well. And it was an interesting collaboration, because that's actually what it turned into, because as like Mohsen was doing this work and other people were collaborating on this as well, because it was quite kind of welcomed by the Webpack community, like it emerged that there were all kinds of all kinds of issues like with the TypeScript support. And the TypeScript team were like super interested in this. They just didn't know because this hadn't really been tested out at this scale before. And there was like a back and forth between the TypeScript team and the Webpack team and Mosen and so on and so forth. But you can see various TypeScript names popping up inside there. There's Mohammed. You can see Nathan popping up here and there. And essentially, this was like a wonderfully mutually beneficial exercise in which Webpack got static typing, and TypeScript got like an improved support for JSDoc. They were fixing lots of the issues as they were discovered. So what happened with this PR? Well, it got merged. So I think it took about a month or maybe 3 weeks or so. Yeah. So here's a tweet that Sean Larkin of the Webpack team put out at the time. 9 valid JavaScript in Webpack bugs were caught and killed. So like static typing, like annihilated sort of 9 issues in Webpack as a result of this. There was 15 pull requests from Mosen, and there was 10-ish issues found and unblocked by the TypeScript team and the definitely typed peeps. And from that point forwards, Webpack was statically type checked with TypeScript JSDoc, and it has been like a great saver in terms of like finding issues and things like along the way. And in fact, a thing that I did related to that was I contributed support for loader context to Webpack. So like the initial PR that landed wasn't like all of Webpack. Webpack's very big, but it's over time it's like gone out and out, and loads of people have contributed, of which I'm just one. So what happened after that? The TypeScript 2.9 shipped, and although it wasn't like mentioned in the release notes, it's actually featured like lots and lots of improvements, the fixes that were found doing the Webpack work to the like to the JSDoc support, and like from that point forward, it's just improved with each version that comes out. And in fact, a significant change happened with TypeScript 3.7, which it's worth digging into for a second. So TypeScript has always had this ability to when it compiles, to omit the JavaScript, of course, which is the running code, but also to omit type declaration files, the sort of thing that we were looking at earlier with the declaration imports. And with TypeScript 3.7, it became possible to write JSDoc and to omit TypeScript declaration files. And this is an example from the TypeScript release notes. Actually, you can see here's a piece of JavaScript code. You can see it's got the JSDoc for the function on here. And as of 3.7, when you compiled your JavaScript, it was possible to then produce declaration files off the back of it like this. You can see this is a DTS file, which just describes the shape of that function there. But it's proper TypeScript that's been omitted there, which was really, really powerful. And this is a thing that Webpack uses as well. So TS Loader started consuming the types from Webpack earlier this year. I think it was like February, something like that. And yeah, it's just tremendous to be able to directly use like the real generated types as opposed to definition files, which previously like were often incorrect or just slightly wrong here and there, which led to issues. So that was like a magnificent addition. I've been kind of singing the praises of JSDoc like to a large extent, and it is a great thing. But it's worth bearing in mind that it has limitations, and I think one of the limitations that's probably clear is that it's definitely less fun writing like JSDoc directly than writing TypeScript. Or it's a noisier experience. I'd argue that the developer experience is less good for JSDoc than it is for TypeScript, and it's also worth knowing that JSDoc doesn't have feature parity with TypeScript. So pretty much most features in TypeScript land in JSDoc in the end, but it's not a priority that they do for the team. Like TypeScript directly is like more the focus. An example, for instance, is the as const support that was in TypeScript 3.4, and it landed just like this last month in 4.5 in JSDoc land. So it's worth knowing that if you wanted to use JSDoc, like you might find yourself not being able to use like all of the amazing features that exist in the form of TypeScript, but it's a worthwhile thing to consider and compromise upon. What should you pick? So if you're building a code base and if you're like the Webpack team and being in JavaScript like really matters to you for whichever reason, it's worth like optimizing for that and going with that, because it will work and it will serve you well. JSDoc will suffice. In fact, the Webpack team was actually thinking about static typing for quite a long time before this came along, and there've been discussions about like potentially using Flow, potentially using TypeScript, and maybe even other things too. But the thing that was really important to the Webpack team was we really want to have that like immediate feedback loop of being able to run like the code that we're writing directly. If it really matters to you that you're running the code that you're writing directly, then JSDoc is clearly the thing for you to go for. If you prefer a slightly less noisy developer experience and you're cool with an emit stage, then TypeScript is probably the direction that you may want to consider going in. But yeah, both of them are tremendous, and I would recommend static typing just generally as a useful property. That's kind of the end of the talk. There's a bunch of links here that I'll share with Luke so that he can put into the chat, and I'll stop sharing now. And if people have questions, then please do feel free to ask. I'm happy to respond.
Cool. Any questions out there? Seems like a no. Good stuff. Have you ever come across like a code base that's kind of in like both land? Like they
no
doc and some TypeScript, and it's just totally confusing.
No, I think it's generally encouraged as like this. It's encouraged to be like a stepping stone. The idea is that people would either probably like use it as a road to traveling towards using like TypeScript directly. And but yeah, I often use it on so if I write a lot of like little scripts using JavaScript, and having like I like static typing like a lot, but I don't always want to have like an emit stage if I'm writing a script, because like script is just like throwaway. So I'll often use it in that context there. Like it just really is useful.
Cool. All right. Yeah, like for a migration over, it seems good way to get it done.
Yeah, but there are people who just like they really love like using like their code executing exactly the stuff that they've written, and it's a great choice for that use case, for that scenario.
Right. Cool. All right. Well, thanks a lot, Sean. Like I said, yeah, I'll send the recording around, and yeah, have a good rest of your day.
Cool. Thanks, everyone.
See ya.
Cheers.